Hi, this is Alex from devstories.eu. GitHub Actions, episode 9 of 14. The most secure cloud credential is the one that expires 5 minutes after your deployment finishes. Yet, many teams still copy long-lived administrator keys into repository settings, hoping they never leak. Today, we fix that by looking at passwordless cloud access via OIDC. Historically, connecting a GitHub workflow to a cloud provider meant generating an access key in AWS, Google Cloud, or Azure and saving it as a long-lived GitHub secret. If that secret leaked, anyone could use it from anywhere until an administrator manually revoked it. People often think OpenID Connect, or OIDC, is just a new type of secret you paste into your repository. It is not. OIDC replaces stored secrets entirely. It is a protocol that generates a dynamic cryptographic token on the fly to prove the workflow identity to your cloud provider. GitHub acts as an identity provider. When a workflow runs, it can ask GitHub to issue a JSON Web Token, or JWT. To make this happen, you must add a specific permission to your workflow file. You set the permissions block to allow write access for the ID token. This tells GitHub the workflow is authorized to generate an identity credential. Here is the key insight. This token does not grant access on its own. It is simply a digitally signed document containing claims. Claims are pieces of metadata that state verifiable facts about the workflow currently running. The token includes the repository name, the organization, the branch, the environment, and the event that triggered the run. Because GitHub cryptographically signs the token, your cloud provider can trust these claims. This forms the foundation of a zero-trust deployment. Let us look at a deployment job pushing an image to an AWS Elastic Container Registry. The workflow starts and requests an OIDC token from GitHub. The token is generated containing claims that verify it comes from the main branch of your backend repository. The workflow then sends this token to AWS. AWS first checks the digital signature to ensure the token actually came from GitHub. Then it reads the claims. It checks these claims against a strict trust policy you defined earlier. The policy might say it only accepts tokens from your specific repository and only if the workflow is running on the main branch. Because the claims match, AWS accepts the token. AWS does not return a permanent key. Instead, it issues a temporary access token. This token might be valid for just 15 minutes. Your workflow uses this temporary credential to push the container image to the registry. When the job finishes, the credential expires. There is nothing to rotate and nothing stored in GitHub that an attacker could extract. When setting this up, pay close attention to the subject claim, often called the subclaim. This is the primary field cloud providers use to filter access. By default, GitHub formats the subject claim to include the repository name and the Git reference, such as the branch or tag. You must ensure your cloud trust policy strictly validates this subject claim. If you only check the organization name, any repository in your organization could request cloud resources. By linking temporary cloud access to specific workflow metadata, you guarantee that a compromised repository cannot touch your infrastructure unless the request comes from the exact branch and environment you explicitly trust. That's all for this one. Thanks for listening and keep building.